Ever feel that tightness in your chest after a huge meal? Like, ugh, gotta relieve some pressure. Weird feeling, right? Get ready to dive into a world where pressure is a whole different beast.
Very varied.
We're going underwater, and I mean, literally.
You're in for a wild ride. The deeper you go, the more intense this force gets. It's not just like feeling full anymore.
Right.
It's the actual weight of the water pushing down what we call hydrostatic pressure.
Hydrostatic. Okay, that sounds kind of intimidating.
It's simpler than it sounds.
Okay.
Like pressure is force over a certain area, right?
Yeah.
Imagine a 1 kilogram weight pressing down on a tiny, tiny square centimeter.
Okay.
That's how much pressure we're dealing with every day from the atmosphere.
Wow, it's like we've got these invisible weights all over us that we just don't even notice. That's kind of mind-blowing.
Our bodies are seriously adaptable, but let's talk about what happens underwater.
Okay.
Just going down 10 meters is like stacking another whole atmosphere's worth of weight on top of you.
Hold on, seriously. So going for a casual swim is like being on top of a mountain pressure-wise. No wonder the deep ocean is like crushed depth.
It's true. At just 20 meters deep, that pressure triples compared to the surface.
Okay, now that's just wild. I suddenly have a new respect for deep-sea creatures. But thinking about us land dwellers, that kind of pressure's gonna make breathing a challenge, no.
Totally. Our lungs depend on this super delicate balance of internal and external pressure. Imagine trying to inflate a balloon underwater.
Oh,
The
yeah.
deeper you go, way harder it gets.
So how do CB divers manage to breathe at those crazy depths? They don't carry mini atmospheres in those tanks, do they?
That's where SQBD gear gets really clever. Their tanks store air at a whopping 200 bar.
Whoa, hold on, 200 bar.
Yeah.
That's like 200 times more than what we're breathing right now.
200 times the pressure, exactly. And to make sure that doesn't blast into their lungs,
Right.
they have a regulator. It acts like a pressure gatekeeper, basically steps down the tank's pressure to match whatever's around them in the water.
That is amazing. So it's all about keeping things balanced, the pressure inside and outside the lungs, right?
Exactly. That's how we can breathe underwater, and this is where understanding that difference between hydrostatic pressure, the weight of the water itself,
Right.
and absolute pressure becomes super important. Absolute factors in the atmosphere's weight on top of everything else.
So when divers check those depth gauges, they're actually seeing the absolute pressure where they're at.
That's wild. It's crazy how much goes into making sure they can breathe down there.
It really highlights how science and engineering have to work together. And that absolute pressure reading is vital for their safety, kind of like a fuel gauge for how long they can stay underwater.
Okay, that makes total sense. It's not just about depth, but your body's total pressure load.
Yeah.
What about when they come back up, though? Does the body just magically readjust?
Well, not magically, but it does readjust.
Okay.
And that process is key to understanding why going up too fast is a really bad idea. It does, and it's a process.
Okay.
And that's really why going up too fast is a bad idea.
So think about it. As a diver goes down, the pressure's increasing, right?
Right.
That actually causes their body tissues to absorb more nitrogen from the air they're breathing. It's like the water's kind of pushing that nitrogen into their body.
Well, okay, like shaking up a soda bottle, right. All that pressure builds up, then you open it and whoosh.
Perfect analogy. Maybe not quite as dramatic in our bodies,
Right.
but the principle's the same. If a diver ascends too fast, all that nitrogen that's dissolved, it doesn't have time to be released safely through their breath,
Right.
like opening that soda bottle too quickly.
Right.
Sudden pressure change makes the gas come out of solution all at once.
And that's when divers get the bends, right? I've heard those stories about like old-time deep-sea divers, coming up too fast and having crippling joint pain.
Exactly. Decompression sickness, or DCS.
Yeah.
And it's no joke. That dissolved nitrogen forms bubbles, basically, in the bloodstream and tissues.
Oh, wow.
And it can cause a whole range of problems, from mild joint pain all the way up to, in severe cases, neurological problems or even death.
That's scary stuff. It
Yeah.
really makes those safety stops divers do on the way up seem way more important. I always thought they were just catching their breath and enjoying the view.
Well, they can certainly enjoy the view, but yeah, those pauses at specific depths, they're crucial for letting the body off-gas that nitrogen safely, like slowly releasing the pressure from that shaken soda bottle bit by bit so you don't get a fizzy explosion.
So it's all about managing those pressure changes gradually, both ways, down and up. Our bodies are amazing, but they need a little help from like physics and careful planning to handle these extreme environments.
Totally.
Yeah.
It really highlights how ingenious SQV gear is and how important it is to get these pressure basics.
Yeah.
It's not just about, the thrill of deep, right?
Yeah.
It's respecting the science that makes it possible at all.
Right, absolutely. It's like we're hacking our own physiology to check out a whole different world, but responsibly, right? Speaking of which, we've been talking a lot about us humans and our, issues with pressure.
Right.
What about creatures that live their whole lives in the deep? They don't have zesty bay tanks and decompression chambers or anything.
That is a fantastic question. It takes it to a whole nother level of like
Oh,
awe-inspiring adaptations.
right. It really is amazing when you think about it. We've been talking all this time about how dare you handle the pressure with all our fancy gear.
Right, right.
But what about the creatures that just live in the deep? No Scooby tanks for them.
It's mind-blowing the adaptations they've developed over time.
Yeah.
Take sperm whales, for example.
Mm.
These guys dive hundreds of meters to hunt.
Oh, yeah.
Talk about pressure. We can't even imagine, like, crush a human submarine kind of pressure.
Whoa.
And yet, they don't just survive, they thrive down there.
So what, do they have some secret internal SQB system we haven't figured out yet?
Even cooler than that, their lungs, get this, they actually collapse
What?
under all that pressure.
Whoa.
Yeah, it forces air into their windpipe and naval passages,
Oh,
places
yeah.
where it can't get into the bloodstream. So no nitrogen buildup, no bends for them.
Collapsing their lungs on purpose. That's both terrifying and genius.
Evolution, right. And that's just one example. Deep-sea fish, they've got all sorts of tricks.
Like what?
More flexible rib cages, special proteins that help them withstand the pressure.
Wow.
This whole different world down there, shaped by forces we barely even think about up here.
It really makes you appreciate how diverse life is on this planet. The lengths, or I guess depths, that creatures have gone to adapt to their environments is incredible.
It really is. Life finds a way, even when it seems impossible.
It's true. So next time I'm feeling the pressure, I'm going to channel my inner deep sea creature.
There you go.
It's been quite a deep dive today, exploring this invisible force that shapes so much of our world.
Absolutely. And
Yeah.
hopefully folks came away with a new appreciation for those incredible creatures that call the deep sea home.
Yeah.
Wouldn't have said it better myself.
Yeah.
Until next time, everyone, keep exploring, keep those questions coming.
Yeah.
And thanks for joining us in the deep dive.